Hi, this is Chris from Power Ultrasonics. Today I'm going to demonstrate our freeware demonstration package, SonoAnalyzer Free. As you can see, I'm running Windows 10 here, but the process is the same for all versions of Windows back to Vista. You can also use either the 32 or 64-bit version to run SonoAnalyzer. I'm going to start by opening a browser window and just going to sonoanalyzer.com. So, the free software is discussed in detail here. And down at the bottom of the page, you'll see a link to the downloads page, which is also at the top here, where you can obtain the download files. At this point, we're looking at SonoAnalyzer Free version 1.6.4, and I'm going to start by downloading that. Once it's downloaded, Windows will run a security scan. And once that's done, we can run the installer. Just minimize the browser. Now, it's very important at this point to notice that the verified publisher here is Power Ultrasonics. If you don't see that, you may have a corrupted download or even a fake version that could be malware. All genuine SonoAnalyzer software will show this verified publisher, Power Ultrasonics. So I'll just hit the install button. And we can run the program. Now, this is the typical SonoAnalyzer user interface, common to all versions. On the right is a 3D view of the sonotrode you're modeling. You can rotate it to view from different angles, zoom in, zoom out, and just move it around if you want to. If you ever want to go back to the standard display, reset will put it back where it started from. On the left here you see a series of tabs describing what you're trying to model. So first, the analysis tab has a set of different types of analysis we can do. Currently there's only one available, this one. The results tab ultimately will show some frequencies that we've analyzed, but nothing there yet, so we'll move on to the dimensions tab. And here we see the dimensions of the sonotrode we're analyzing. I like to work in millimeters, so we can switch to dimensions metric and it'll convert all of the dimensions used within SonoAnalyzer to typical metric units. You can also choose imperial inches if you prefer. And here we can set the dimensions of the sonotrode, and finally materials. Got a series of standard materials you can choose, or there's a user-defined option, and you can specify a material of your own. So let's get on and do something. I'll click on Calculate, and almost instantly it comes back with a result. These database-driven models have some limitations, as I'll come back to later, but their advantage is they're very fast indeed. So going back to the Results tab, I now have a set of frequencies and a set of modes. The A1 is the one it starts in, typical axial mode that you expect to find for a sonotrode. And there are some bending modes. And there's a higher harmonic axial mode called the A2. It's important to realize that there are all these different modes of vibration for every sonotrode you could imagine. We normally think of a sonotrode having a particular mode of vibration, just the one we want, but in reality there are always more. Now, what this shows is that the current design has a frequency of 24.8 kilohertz. Supposing we wanted that to be 20 kilohertz, well, if you've ever been involved in tuning a sonotrode, you'll know that reducing the length will increase its frequency. If we want to do the opposite, we want to reduce the frequency, so we need to increase the length. Now, with a physical sonotrode, it's not easy to add length, but here it's not a problem. You can just change 100, let's make it 110. And we'll hit calculate again, get a new answer. See that the frequency is actually shown here as well, but on the results tab, 22.6 kilohertz. So it's come down a bit, but it's still more than we want for 20 kilohertz. So let's go back and change the length to 120 millimeters. Okay, now we have a problem. See the yellow warning bar at the bottom is saying this is a demo model only, the inputs are out of range, please install the full database. Now the point here is that the database packaged with SonoAnalyzer free is just a very minimal one covering a small range of dimensions. And you'll see the same sort of message if you change any of the other dimensions or even the materials. So as the message says, we need to install the full database. That's also a free download. It's not included in the main package though, because it's a relatively large file and it's easier just to download it separately. So I'll go back to my browser, and next one down in the list here is free database models. Okay, I'll hit download on that. Depending on your connection speed, this may take a little longer for you, but I have quite a good connection to the server in this particular case. Okay, so that's finished downloading. It's running a security scan, and we don't even, in fact, need to open this one. Just go back to SonoAnalyzer and do a file, install DB files. And now if I go to downloads, there's the freedb.zip that I've just downloaded. I'll open that. I'll just hit clear here. And a few moments later, it should say the data is extracted and it's found 3 database files. Okay, go back to the analysis tab, and now you'll see we have some more analyses available to us. First one is this, which looks identical to the one we've just seen, but because it's the full version, it has a wider range of dimensions. There's also a tube model and a ring model that you can choose from. For now, I'm going to go back to the stepped cylinder model again. And I'm going to go back to the dimensions, and we wanted to make that 120. Okay, and calculate. So this time it works, and we're not limited by the smaller range of the package that's included database that's included with the free package. Now, looking at the results again, you'll see we're still a little bit over the 20 kilohertz target. We may want to make that 125. And now we've got almost bang on 20 kilohertz. Now, apart from changing the length, you can also change these diameters to a certain extent, but not too much. So I could make it 40-20, for example, 40-30. But if the diameters go too far out of range, I'm going to try and make it 40-50, for example, it won't like that. Then we could make it probably 40-40 or 50-40. So it covers a fairly wide range of dimensions, but if you try to go too far, it'll say you're out of range. You can't do that. Also, this 3mm blend radius in the corner here, that's fixed, you can't change it. And that's really the limitation of the database-driven models. Even to create the ones you see here, it's taken thousands of separate finite element analyses, and it's just not possible to cover a wider range than this using this method. So to do that, you need to take a different approach and instead run a finite element analysis on demand for the particular set of dimensions chosen by the user. And that's exactly what you can do with SonoAnalyzer OE and Pro, the paid versions of the program. Now, those options aren't available in SonoAnalyzer Free, but what you can do is view the saved results files. SonoAnalyzer uses a file extension .saz for complete results files, and you can download some examples from the website. So I'll go back again to the downloads page of sonoanalyzer.com. And here we have some example results files. Again, hit download. Okay, and this time I'll open that zip file. See that they're saved models. I'll just extract them. Extract all. Okay, so now in my downloads I have the saved models.zip, and I have a new folder called saved models. Now the file names here give you a reasonable indication of what's contained in them. I'm going to start by running through some of the OE models. So starting with a stepped hollow OE model. And here it is. And here it is. The immediately obvious difference with this being a hollow model is there's a hole through the middle. That's optional. If you go to dimensions, you can just set the hole diameter to 0 if you wanted a solid model. But you'll see also there are additional things you can change here. The radius is variable, the lengths of the top part and the overall length are variable independently. So it gives us a little more flexibility than we have from the database-driven models. So for example, I can also set the length to automatic at 50%, and now if I change length to 224, the top part is automatically made 50% 112 long. You'll also find that the ranges generally are more forgiving. You can allow for greater variation between input and output diameters, greater variation of length. And of course, if you don't want the hole through it, just specify 0 for the hole. You may have already noticed, though, that as I change dimensions, I get this warning message at the bottom: demo mode only, creating new geometry is not supported. And what that's saying is that it's a limitation of the free version. You can look at the SonoAnalyzer OE models, but the only result you can see is the one that was included in the original file. What you can do, though, is explore the limits of the inputs. So what you see here is that 120 is showing its demo mode only. If I was to go to 200 diameter, now it says one or more inputs is out of the allowed range. And you will also see that the 200 diameter is shown in red. So what that's saying is that 200 millimeters input diameter is out of the valid range for this particular OE model. You can investigate the ranges more on the website if you go to the manual section and then OE models. And somewhere near the bottom you'll find this hollow stepped sonotrode model here and the dimensional ranges that you can use with it. And what we see is that the input diameters, input and output, can vary from 2.5 to 100 millimeters. Let's go back to SonoAnalyzer now and take a look at some of the other models that were available. So I can do this either by using File Open. No, I don't want to save that. And selecting a different saved model. So for example, conical. Alternatively, I can just go back to my File Explorer and look at the let's say user-defined. That opens up the user-defined model in here. User-defined gives you the choice of specifying your own shape for the outside profile of the model. So by defining a series of diameters here and lengths here, blends here, you can create pretty much whatever shape you want. This one also allows you to use a hole through the center of the sonotrode. And that's the user-defined model. Don't want to save that either. Go to a stepped block. So this is a rather simple block model sonotrode. One thing the limitation of the block models in SonoAnalyzer OE is that slots are not included, and the maximum width dimensions. The maximum width here is 100 millimeters. In reality, 100 millimeters is about the limit for a non-slotted model. Even as we see at 80, if you look at the amplitude on the end surface, it's getting a little bit uneven. Okay, so if you need to model more complex sonotrodes than these OE options allow you to do, the Pro models may be the answer. So I can open some Pro models here, starting with a stepped slotted block. It's just taking a little while to start up. Now this is interesting because, as you see, what it thinks is the axial 1 mode is not what most people would describe as an axial mode. And this is demonstrating some of the issues with unwanted modes. As soon as you go to more complex models, you will find some very strange modes like these appearing at frequencies that may or may not be a problem to you. In this case, 9,700 kilohertz, 9,700 hertz, it's probably not a big deal if you're running at 20. We need to look elsewhere for the actual, I think it's mode 24, the actual axial mode is up at 18.5 kilohertz. But this again is a stepped model with a variable radius that you can choose. As you can see, I've chosen quite a large radius here, and input and output, input and overall lengths can be specified. You can also choose the number of slots, the length of the slots, the position of them. We open the user-defined slotted block. This is a more complex shape. Defined as before for the user-defined shape by a series of lengths and widths, thicknesses. And in this case, we've got 2 slots defined. And we're finding an axial frequency of 17.5 kilohertz. Now, there's a lot more information available in SonoAnalyzer OE and Pro, but again, we can get a taste of it here. For example, you may want to know the stress levels in a sonotrode. To get this in SonoAnalyzer OE, you would go to the FEA menu here and download a stress plot. So this is the stress calculated by the finite element analysis as shown in the Calculix post-processor. And in the full version, you can get similar plots of all sorts of things like displacement, axial displacement, and so on. But here, as it's the demo version, you're limited to only those plots that have been included in the results file. So the rest of the options are grayed out. And it's also worth noting that the stresses are dependent on the mode of vibration. So if I switch to another mode, in this case there's no extra information included in the file, so no options are available for download. Of course, in the full version you would have these choices available to you. You would also have some extra options in the Pro version, which will be shown in a later video. Coming back to the example model files, the Pro range of axisymmetric models is similar to the OE range, so it includes exponential, stepped, conical, and as here, the user-defined. But again, Pro offers a little bit more. Here's the user-defined shape we saw before, with a hole through the middle. But if we look at the hole, we can now see that this one is defined like the outside profile by a series of diameters and lengths and blends. So this model allows you to define a profiled hole through the center of the sonotrode, or 2 blind holes, one at each end of the sonotrode, or whatever you like. So that's a brief introduction to SonoAnalyzer Free. It can run some simple analyses on its own and view results saved from the other SonoAnalyzer versions. In the next video, I'll be showing some more interesting models and more advanced usage. Remember, everything you've seen here is available as a free download from sonoanalyzer.com, so if you're interested, grab a copy, test it for yourself. Thanks.